Welcome to the Chemistry, Biology and Math Revision Hub. Today we're doing the Pearson Edexcel International A-Level Chemistry Unit 6 for June 2023. Let's begin with the first question. Question 1. A student investigated two aqueous solutions labeled P and Q. Both solutions were green, and each solution contained one cation and one anion. Because the solutions were green, it could be nickel 2 plus or chromium 3 plus. So they say complete the table. In the first test, a few drops of aqueous sodium hydroxide were added to 5 centimeters cubed of P. The inference is chromium 3 ions may be present. If chromium 3 ions are present when a few drops are added, this is going to be a green precipitate. And they say more sodium hydroxide solution was added to the mixture from A1 until there was no further change. If you add more sodium hydroxide, then it means there is going to be further deprotonation, and then a green precipitate will dissolve to form a green solution if it's confirmation that chromium 3 ions were present. The next they say a few drops of dilute nitric acid were added to 5 centimeters cubed of a fresh sample of P, and a few drops of aqueous silver nitrate were added to this acidified solution P. Adding dilute nitric acid followed by silver nitrate, we are testing for halide ions. So if a white precipitate forms, then this halide is going to be chloride. So here they ask the formula of the anion likely to be responsible for the white precipitate, and that is going to be a chloride anion. In part B, state why in the silver nitrate test on P, the nitric acid was not needed in this case, and justify your answer by considering the role of nitric acid in the silver nitrate test. Nitric acid is needed in order to react with any interfering anions like carbonates as well as hydrogen carbonates. So here I say nitric acid is needed to remove any interfering anions like these, and nitric acid was not required because chromium 3 plus carbonate is not going to be a solution, it's going to be an insoluble sample. They say the student carried out tests on Q and inferred that it was a solution of iron 2 sulfate. The addition of dilute aqueous ammonia to a sample of solution Q produced a green precipitate which changed color on standing. In this case, iron 2 is going to be the green precipitate, and if it changes color on standing, it's because the iron 2 has been oxidized to iron 3 plus by oxygen in the air. So they say explain why the color change led the students to infer that Q contained iron 2 ions. This is because the color changed from a green precipitate to a brown precipitate, and this is confirmation that iron 2 has been oxidized to iron 3 by oxygen in the air. A reaction that is going to take place is from this solid to that. So those are the two precipitates with the different colors. And in the next part, they say describe a test and its positive result that the student could have carried out to show the presence of sulfate ions. To test for sulfate ions, you need to add nitric acid followed by barium nitrate. And if this is carried out, a white precipitate is going to be formed. That is proof that a sulfate anion is present. In part D, they say identify by name or formula a metal cation other than chromium ion or iron 2 ion, which could give a green color in the aqueous solution. This could be nickel 2 plus or vanadium 3 plus. So this brings us to the end of question 1. Let's continue to question 2. In question 2, they say two organic compounds X and Y are colorless liquids. Each compound contains only one functional group. A few drops of deionized water are added to a beaker containing X, and misty fumes are formed. They say a drop of concentrated ammonia on the tip of a glass rod is placed in the misty fumes and white smoke forms. They say deduce the functional group in X and justify your answer by referring to the observations. The functional group is going to be an acyl chloride, and this is because addition of water caused the substitution reaction to occur, whereby the Cl in the acyl chloride was replaced by OH from water, and then the Cl and the H reacted together to form HCl, and this HCl reacted with ammonia to form ammonium chloride, which appeared as white smoke. The next part says state the precautions that you would take to minimize the risk of carrying out this test on the misty fumes. And they say assume gloves, safety goggles, and laboratory coat are worn. Because the misty fumes, which is hydrogen chloride gas, is toxic, you have to work using a fume cupboard. So that is the answer there. And next they say the carbon-13 NMR spectrum of X has 2 peaks. They want you to draw the displayed formula of X. Because the carbon-13 NMR showed only 2 peaks, and this is an acyl chloride, we already have a carbon or one carbon environment here. So it means the other carbon environment is going to be due to a CH3, so this is my possible structure. Next, they say the mass spectrum of Y is shown, which is this one here. We have the relative intensity and we have the mass to charge ratio. Then they say bubbles are produced when aqueous sodium hydrogen carbonate is added to Y. They want you to deduce the formula of the ion responsible for the peak at mass to charge 45. Now, because this produced bubbles with sodium hydrogen carbonate, it means the functional group present is going to be carboxylic acid, and therefore the ion corresponding to mass to charge 45 is going to be this ion here. And next they say draw the structure formula of Y. Because Y is a carboxylic acid, and when we look here, it has a mass to charge, which is 74 as the molecular mass. We can know if this is equal to 45, this is going to be 29 to create a 74 in total. So this was a CH3 and a CH2 and then the carboxylic group due to this ion here. In part D, they say both X and Y can be used to produce esters. They say name the compound that would react with both X and Y to form ethyl esters. Because they say ethyl, it means we're going to have CH3CH2. It's going to be ethanol. The next part says a student prepared an ester using X and a suitable compound. They say explain why the student added aqueous sodium hydrogen carbonate to the reaction mixture to allow the presence of an ester to be detected. The key thing here is there is going to be HCl produced as well as an ester, and this HCl gas is going to be non-toxic, but there is a different smell. So this is going to mask the smell of the ester. So when you add sodium hydrogen carbonate, it's going to react with the HCl to cause neutralization so that the HCl is used up, and then the smell of the ester can be detected. So I say the reaction to form an ester produces HCl, and addition of sodium hydrogen carbonate reacts with HCl. This removes the HCl smell, so the ester smell can be evident. In part E, both X and Y react with concentrated ammonia, but form different products. They say identify these products by name or formula. When the acyl chloride reacts with concentrated ammonia, we form ethanamide, which is this one here, as well as ammonium chloride. And when it reacts with product Y, we form ammonium propanoate, which is what we see here. So this brings us to the end of question 2. Let's continue to question 3. In question 3, they say this question is about an experiment to investigate the kinetics of the reaction between iodine and propanone with a catalyst, which is an acid. This is the equation for the reaction. They say to obtain the order of reaction with respect to iodine, the concentration of iodine in the reaction mixture was determined at various times. So the procedure is as we can see here. So they say mix 25 centimeters cubed, 1 mole per decimeter cubed sulfuric acid with 25 centimeters cubed, 1 mole per decimeter cubed propanone in a beaker. Then start a stop clock as 50 centimeters cubed of this concentration of iodine solution is added to a beaker and mix the reactant thoroughly. Then step 3, tip a spatula measure of sodium hydrogen carbonate into the conical flask, and after 3 minutes, pipette 10 centimeters cubed sample of the reaction mixture into the conical flask and mix thoroughly. Here this is quenching before you can go on to titrate. In step 4, they say titrate the iodine in the sample with 0.01 mole per decimeter cubed sodium thiosulfate solution using a suitable indicator. This is touch indicator. Then you record the titer. And in step 5, repeat step 3 and 4 every 3 minutes to obtain 4 more titers. State why the sulfuric acid and propanone concentrations are both much larger than the iodine concentration. Because we want to study the effect of changing the concentration of iodine on the rate, the other concentrations have to be a large excess so that they do not affect the rate. So I say they are a large excess to ensure that only iodine has an effect on the rate. In part B, they say state why sodium hydrogen carbonate is used in step 3. Sodium hydrogen carbonate is used as a quenching agent so that the reaction can be stopped before the titration can be carried out. And in part C, they say name the indicator that would be used for the titration in step 4, stating the color change that would be seen at the end point of the reaction. This is going to be touch indicator, and the color changes from blue-black to colorless. In part D, they say titration results from the experiment are as we can see here, and they want us to plot the graph of the titer against time. If I make it smaller, this is what we see. On the vertical axis, we have the titer values, and on the horizontal axis, we have the time. I had to draw my graph with labels and units on both axes, and then plot the corresponding points and draw a line of best fit through them. This is quite easy. These are the corresponding points we can see there. And then my drawn line of best fit. Next, they say state why the volume of thiosulfate may be used for plotting the graph rather than the concentration of iodine. This is because the volume of thiosulfate is actually directly proportional to the concentration of iodine, so there is no need for us to find the concentration if we already have the volume of thiosulfate. Next, they say state the order of reaction with respect to iodine and justify your answer by referring to the graph. When we look at our graph here, it is a straight line that is slanting, meaning it has negative gradient. This is because it's zero order with respect to iodine. So here I say zero order because it's a straight line with a negative gradient. Then in part E, they say further experiments were carried out to determine the reaction orders with respect to propanol and sulfuric acid. And this graph here shows the concentration of propanol against time. We can see the graph, concentration of propanol on the vertical axis and the time on the horizontal axis. And here I was able to find the first two half-lives. We can see from 0.2 to 0.1, I saw there were 7 seconds. And from 0.1 to 0.05, there were 8 seconds. So here they say the reaction is first order with respect to propanol. They want you to determine two half-lives for this reaction, and you must show you're working on the graph. Like I already showed, the first half-life is 7 seconds, and the second is 8 seconds from the previous graph. Next, they say a graph of the reaction rate against the concentration of sulfuric acid is shown. We can see this is rate versus concentration, and it's a straight line through the origin, meaning this is first order with respect to the acid. And finally, they say deduce the rate equation for the overall reaction of iodine and propanol with an acid catalyst. Use your answer from D3 and the information from E1 and the graph in E2. From the third graph, which is this one here, we can see it's a straight line through the origin, so it's going to be first order with respect to the acid. And when we go back to the previous graph for propanol, we saw it was constant half-life, so we can say still first order with respect to propanol. But the first graph had a negative gradient, and we can see this is going to be zero order with respect to iodine. So the overall rate equation is going to be rate is equal to K, concentration of propanol power 1 times the concentration of the acid power 1, because the order with respect to this and this is both 1. So this brings us to the end of question 3. Let's continue to question 4. In question 4, a group of students prepared methyl 3-nitrobenzoate by the nitration of methyl benzoate. We can see the reaction taking place. The procedure is step 1, measure 9 centimeters cubed of concentrated sulfuric acid into a small dry conical flask. Label flask A and place it in an ice water bath. Add 4 centimeters cubed of methyl benzoate to flask A and then gently swirl. Then mix 3 centimeters cubed of concentrated nitric acid and 3 centimeters cubed of concentrated sulfuric acid in a test tube to form the nitrating mixture and place this test tube in the ice bath. Then place a thermometer in flask A. Add the nitrating mixture very slowly to flask A using a dropping pipette. While doing this, you have to take care to ensure the temperature of the flask contents does not rise above 15 degrees Celsius. Then remove flask A from the ice bath and allow it to stand at room temperature for about 10 minutes and pour the reaction mixture into a small beaker containing crushed ice. Then you stir the contents of the beaker with a glass rod. Allow the ice to melt, separate the solid methyl 3-nitrobenzoate by suction filtration, and wash the solid with a small amount of the ionized water and then with a little ice called ethanol. Then recrystallize the methyl 3-nitrobenzoate using ethanol as the solvent. Then determine the melting temperature of the purified crystals of methyl 3-nitrobenzoate. The first question says an ice bath is a mixture of ice and water in a beaker. They want you to suggest an advantage of using an ice bath in step 1 and 3 rather than a beaker containing only ice cubes, and justify your answer. The ice cubes are going to be bigger while the ice bath has smaller particles of ice, and that is going to increase the surface area for cooling. So I said an ice bath provides faster cooling because the small ice pieces provide greater surface area for cooling than ice cubes only. In part B, they say side products from if the temperature rises above 15 degrees Celsius in step 4. They say give the structure of one side product that may form. Remember that step was about nitration, and if the temperature goes above, there is going to be a higher rate, so we're going to have more nitration products. Instead of having just the nitro here like intended in the question, there'll be further reactions creating a nitro here as well, as we can see here. Then the next part says one student drew the suction filtration apparatus in step 6 as below. We see the base of the Bachner funnel, and this is the flask. They want you to identify the 3 ways in which this diagram is incorrect, and they say you may assume that the apparatus is suitably clamped. So there should be a pathway leading to the suction pump here. There should be a suction pump attached as well as a filter paper at the base of the Bachner funnel. So I say there is no side arm on the flask, there is no suction pump or vacuum pump, and there is no filter paper in the Bachner funnel. Describe the stages in the recrystallization of methyl 3-nitrobenzoate in step 7, stating which stages are required to remove the insoluble and soluble impurities. Only outline details of the method are required. Here we begin by dissolving the obtained solid in a minimum amount of hard solvent, which is ethanol, and then you filter while hot to remove any insoluble impurities. Then you cool the solution to crystallize the methyl 3-nitrobenzoate, and then you filter when cool or cold to remove the soluble impurities. Then if you want, you can wash with minimum amount of ice-cold solvent in order to obtain the pure sample. In part E, they say the crystals must be dried before the melting temperature can be determined. They say methyl 3-nitrobenzoate cannot be dried by addition of a solid drying agent such as anhydrous calcium chloride. Suggests why the addition of a solid drying agent is not suitable to dry methyl 3-nitrobenzoate. It will be difficult to separate the solid drying agent and the product which we have made because they are both crystals. So I say the methyl 3-nitrobenzoate is a solid, and using a solid drying agent will make separation of the drying agent and the methyl 3-nitrobenzoate difficult. The next they say state how the crystals of methyl 3-nitrobenzoate could be dried. This could be using a desiccator or using a warm oven. The mass of dry methyl 3-nitrobenzoate crystals prepared by one of the students was 3.05 grams. They say calculate the percentage yield by mass of methyl 3-nitrobenzoate using the data shown. Now we know that methyl benzoate, the volume used from the beginning of the question was 4 centimeters cubed. So we can use this in order to work out the mass. So mass is going to be density times volume. We have the density here and the volume here. We can get the mass, which is 4.32 grams. Because this is our reactant, I can find the number of moles, which should be the mass divided by the molar mass given here, and these are the number of moles. And because the mole ratio between reactant and product is 1:1, it means the moles of methyl 3-nitrobenzoate are exactly equal to the moles of the methyl benzoate. Now the mass of methyl 3-nitrobenzoate is going to be number of moles times molar mass, which is these moles times the molar mass given here, and that gave me 5.75 grams. And since we know percentage yield is actual yield divided by theoretical yield times 100, this is my theoretical yield, and that is my actual yield given in the question. So percentage yield should be the actual yield divided by that times 100, and my answer to 3 significant figures is 53.0%. And finally, they say the melting temperature range of methyl 3-nitrobenzoate is given in a data book as 78 to 80. This suggests a melting temperature range for a sample of methyl 3-nitrobenzoate before recrystallization, and justify your answer. Before recrystallization, this sample is going to be impure. So we know impure samples melt over a range of temperatures, and we know impure samples have a lower melting temperature than that of the pure sample. So I said before recrystallization, the sample is impure, so it will melt over a range of temperature, meaning the range is going to be wider than this. And it will melt below the melting point of the pure sample, so the range is going to be wider and it's going to be lower than 80. So I chose 70 to 76 because the higher temperature here is going to be lower than the given range. So this brings us to the end of question 4 as well as to the end of this whole paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.